In today's session of operating system, we'll be moving on to the next topic, which is related to files. So here we'll be seeing what is a file actually, what are the different file attributes, what operations we can perform on a file, and what are the different file access methods we use. Now, what is a file? What is the general meaning you understand by a file? You have some data. That data will be stored in a format and which we call it as a file, and collection of files we call it as a directory, and collection of this directory is nothing but your file system. So collection of data organized in one particular form is nothing but your file. Now when you go for a file, you might have encountered different types of file. A text file where you just store the data in the form of characters or lines, and we have a source file. Normally when we write a C program or any program, we call that as a source file where you have some executable statements written in this. And we have an object file. When you compile particular source file, it will be converted to an object file where instead of having a normal statements, we have a sequence of bytes. And this particular object file, when we finally execute it, we'll get an executable file, right? So these are the different types of files where you can store the data. So depending on the type of data you are organizing, you can either categorize them as text, source, object, or executable. So what are the different attributes that are associated to a file? It can be a name that you are giving to a file. So what is the name? So when we collect the data, collection of data is a file, right? Now if I want to differentiate between one file and the other file, we have to give a name to that particular file. So a name is nothing but an identity attached to a file. So you can just write the name of the file depending on the data relevant. For example, I'm storing the marks of a student, so I'll just write it as marks. So depending on the data you are storing, you can associate a name to this. Next one is nothing but identifier. So this particular identifier will tell you the type of data that has been stored in a file by means of an extension. So if I'm storing a Word document, so I'll just store this as word.doc. So here doc will tell you that this is a Word document. If it is abc.txt, so it is a text file. So this extension, whenever we give a name to a file, we basically divide it into two parts. First one we'll call it as a primary part, and this is your extension. So dot followed by the extension, and this extension will tell you the kind of file you are using it. And if it is an Excel file, so you extend with .xls. And next is, as we have seen in the previous case, type of the file. It can be an executable file, object file, source code. It can be even a batch file, a markup file, a word processor. You even have some library files when you are linking up your source program with the existing ones, a printable file, or when you compress your files, it can be in a RAR form, zip form, or tar form. And you have even multimedia files. So audio related files, video related files, all these comes under your multimedia. And depending on these file types, the extension will also be changed. So that is used as an identifier. And when I'm storing the data onto a file, you specify the folder where it is actually stored. So d:/, you specify where is the file stored. Next, we even have the size of the file, which indicates the data amount of data that is present in a file, and it is usually measured in the form of bytes, 1 KB or 2 KB. So depending on the content, will designate the size of the file. And for each file, for example, you want some secure data be stored in a file, and you want that file not be opened by all the users. So you can even provide a password to that particular file. So only the corresponding user will be able to open the file and view the data. Even when you are creating a file, that particular file will have a time, date, and you even have a user or the owner who has created the file. So these are different attributes that are associated to a file. Now we have seen what is a file. It's a collection of data, and we know what are the different attributes that are associated to a file. Now on this file, what are the operations I can perform on a file? I can create a file. First of all, if you want to store the data into the file, you have to create a file, right? So creating a file will allow, so you have a corresponding system calls for all these operations, which we'll be seeing in the next class. But as of now, you remember that creating a file will create an empty file for you, And if you want to perform any of the operation, whether you want to perform write operation or read operation, first of all, I need to open a file. If you want to open a file, as we have seen in a C language, we can write f open of, specify the name of the file which you want to open or the path of the file, and even mention the mode in which you want to open, whether you want to open it in read mode, write mode, or append mode, right? Same thing here. So before performing either a read operation or a write operation, we open a file. And once the file is open, you can store the data onto the file, so that we call it as write operation. We can even retrieve the data from the file which is corresponding to your read operation. And reposition or seek operation is nothing but when you are performing a read or a write operation on your file pointer, or you can even call it as a file cursor, will be somewhere in the file. So if your file cursor is somewhere here, you can either bring that cursor at the beginning of the file or to your end of the file. So you can move this cursor. So this you call it as reposition. You can even perform a delete operation where you can to after your work is being done, you can just go for deleting the file. Truncate operation, which will just delete the content of the file, but the attributes that are associated with that particular file, the type, name, and all those things will be as it is, so that it can be used for adding new data. You can even close a file after once you have opened a file, performed your operation, you can even go for closing the file. And the find next one is your append operation. You already have a file open with some content, 3 or 4 lines present here. You can just go for adding your next content from the fifth line onwards. So you can that can be specified when you are opening a file, whether you want to read, write, or append. Rename operation. Once a file is being stored on your system, you can perform a rename operation, means you can give some other name to the existing file. So these are the basic operations which we can perform on a file. Each one has a corresponding system call and the arguments for each of the system call, which we'll be seeing. Now, after storing the file, you want to access the data from the file. So we have different file access methods. The first file access method is nothing but your sequential file access. So what happens in sequential is, assume this is the data or the records present here. This is the beginning of the file and this is your end of the file, and this is the current position of your pointer. So in sequential, you try to access the data sequentially one after the other. For example, if I want to access this R8 record, I need to move the file pointer from R1 till I reach R8. So you cannot directly go to this. So whether you want to go for read or write operation, the file pointer should be moved sequentially one after the other. Coming to the advantage of this sequential access, it is very easy to implement because you need to just move the file pointer one position ahead, right? And here the file data is stored in like lexicographic order according to the alphabetical order. Coming to the disadvantage of your sequential access, it is bit slow. If you want to access the immediate record, the file pointer is here. If you are able to access the immediate record, it is okay. But if you want to access the record somewhere at the last, you have to move sequentially, which takes more amount of time. Adding a new record or deleting a new record or relocating a particular file will take some amount of time. So if I want to add a record here somewhere, you have to move all these records to the previous positions and then go for adding. So adding or deletion, I not say that it is not possible, but it will take some amount of time. The next file access method here we call it as, this is not sequential, we here call it as direct. The previous one was sequential. So direct access method, or even we call this as relative method. So direct or relative method here is, instead of going through the records one after the other, you directly go to the record whichever you want to read or whichever you want to write. So the advantage of this is there is a direct mechanism and you need not move sequentially one after the other, and there is no need of traversing all the blocks. But here the complexity lies in organization of your data, and the next one is it is difficult of implementing. I mean, implementation will lead to some amount of complexity. And even for example, if I want to access a record, I'll just write it as if you want to read a particular record, you can just write as read 43. So the file pointer will directly go to 43 and get the contents of that particular block. So depending on the value which you are providing, the file pointer goes to that location and performs the operation. So here you need to emphasize some security issues on the record. See to that all the users will not be able to directly access the data.